Alright guys, how you doing? Thought I'd make a video on simplifying radicals for you since our lesson was kind of rushed with this, so you can take this, watch this, and maybe get a better understanding of how to simplify a radical. So just want to, what is a radical? A radical is some number that is under a square root. Like square root of 12. Okay? It's a radical. We can simplify this by breaking the number inside the radical into factors, and hopefully some of these factors are what we call perfect squares. If we have a perfect square, that means that we can take the square root of that perfect square and get a whole number. Okay, meaning a perfect square is a number in which it has factors that are the same number essentially. Like, for instance, take 4. 4 is a perfect square because, because 4 just equals 2 squared, meaning 2 times 2. Okay, numbers of this form are perfect squares. And what that means is when I take the square root of 4, I'm going to get 2, because a square root is an operation that tells us what number multiplied by itself gives me this number. In this case, what number multiplied by itself gives me 4? That is 2. A square root just undoes the operation of squaring something. Okay, so let's list out our list of perfect squares here. Right? Okay, so 1 squared is just 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared 36. 7 squared 49. 8 squared 64. 9 squared 81. 10 squared is 100. 11 squared is 121. 12 squared is 144. 13 squared is 169. 14 squared is 196. And 15 squared is 225. Okay, so we're going to use these perfect squares. We're going to break our numbers down into products of perfect squares, as many as we can, factors of perfect squares, and then we take the square root of those perfect squares, and whenever we have left over, we'll stay inside of our square root, and when we take the square root of these perfect squares, they'll be on the outside. Okay, so the lesson kind of tells us like go through and say all of the largest perfect squares. I think we just start off taking a perfect square out, and then you do the same process to the next number you're left over. So instead of doing what they're doing here, okay, I'm going to do it my way. It's square root of 48. So square root of 48, I think of the easiest perfect square factor. Okay, I see 48, I think of 4 and 12. I'm gonna be honest with you. Okay, 4 is generally one of the easiest perfect squares to recognize, so why not set it up like that? So I know that I know that 4 times 12 is 48. So I can say that the square root of 48 is just the square root of 4 times 12. Okay, so now 4 is a perfect square, 12 is not. However, let's see if we can break 12 down anymore into some perfect square factors. Okay, so I also remember that, okay, 4, still my 4 times, 12 is just 4 times 3. So 4 times 3. Alright, so I have, and 3 is a prime number, I can't break that down anymore, so there's no factors of that. So what I have here, I have 3 things being multiplied inside of a square root. There's a property of square roots that allows us to do this. You just break it up into 3 separate square roots being multiplied. Square root of 4 times the square root of 4 times the square root of 3. Okay, so square root of 4. 4 is a perfect square, and we look over here. If you have square root of 4, it's 2 times 2, so the square root of 4 would be 2. So this would be 2, then this would be 2, and then square root of 3 is not on my perfect square list, so I cannot take the square root of it. So it just stays like this, square root of 3. Now let's simplify everything we can right here. 2 times 2, of course, is 4, so I'm left with 4 times the square root of 3, which we don't have to write the dot. We can just write like 4 square roots of 3. And there we go. So sometimes you may recognize bigger perfect squares, like they talked about, the largest perfect square you can recognize out there. And that's okay, right? We can do it that way. However, that's not always clear about that a large perfect square is a factor of a number that you have, okay? So that we don't have to do it necessarily that way all the time. So I'm going to erase all this. Whoops. All right, so let's look at 75. So I'm 75 here. I get an inkling right away. I'm going to try to think of stuff with 5s in it, right? Okay. So look at my perfect square list. The only one with the 5s, the only two with 5s are 25 and 525. So I want to know, does 25 go into 75 at all? And I think about 25, I think of a quarter, 25 cents. Okay. We're going to have 3 quarters. I have 75 cents. So 25 does go into 75. Okay. You can write 75 as 25 times 3. Okay, and remember we can break these two apart into two different square roots being multiplied. So the square root of 25 times the square root of 3. We already showed that the square root of 3 isn't anything. The square root of 25 is just 5. Then times the square root of 3 is left over, and this would be my final simplified answer. Square root of 25 is 5 because 5 times 5 is equal to 25. Alright, this one, 27. Now 27 is not going to go into 4. That's using my go-to perfect square to check because it's an odd number. So next, about 9 would be the next perfect square. And 27 divided by 9 is 3. So we can break this into 9 times 3. And we know already 3 is a, we cannot simplify that at all under the square root. So split these two up. We have square root of 9 times the square root of 3. Then you take the square root of 9, you get 3, and then you leave your square root of 3 behind. And that's our answer. 18. Ooh, okay, this is a even number. It's not divisible by 4 though, but 2 times 9 is 18. So we can say this is the square root of 9 times 2. So taking the square root of this 9, you get 3, and then you're left over with the 2 behind, so it's 3 square roots of 2. Okay, 24 is divisible by 4, so that's cool. So let's do it. Let's write it like that. 4 times 6. Now let's think about 6. 6, the factors of 6 are either 2 and 3 or 1 and 6. None of those numbers are perfect squares, so this cannot be simplified anymore. So I take my square root of 4, I get 2, so it leaves the square root, and we're left with 2 square roots of 6. And the square root of 6 is in simplest form. We cannot simplify that, and that's my answer. 300. Okay, anytime I see something with a number with 2 zeros, I know it's divisible by 100. Okay? Divisible by 100, that's great. For the most part. Yes, it is, actually. Okay? So, 100 is a perfect square, so we take that out. That's an easy giveaway right there. So 100 times 3. Square root of 100, if we go to our list up there, square root of 100 will be 10. Okay, you can look on your own. So, 10 square roots of 3. Okay, how about 40 goes into 40, of course. That's a perfect square. 4 times 10. 10 is just 5 times 2, or 10 times 1, which none of that has any perfect squares. So, square root of 4 times the square root of 10. This is just 2 square roots of 10. And that's our final. Alright, 54. Here we go. Now, 54 let's check. I'm going to check is 54 divisible by 4. This is what I usually do. It's an even number. It looks like it might. 54 divided by 4. Ooh, I get 13.5. So it's not divisible by 4. My next would be to check is 9. Let's do that. 54 divided by 9 is 6. Okay, so let's write it like that. 9 times 6. So I can write this as the square root of 9 times the square root of 6. The square root of 9 is 3. And we showed earlier that the square root of 6 is in simplest form already. So this would be 3 square roots of 6. 8. All right, 180 here. I think there's a bunch of different ones we can go about doing this. Like, for instance, 180 divide 4. Start with that one. You get 45. So let's take it. Let's take it that root. Okay. So square root of 4 times 45. I have one square root. Let's leave it alone. Let's try to look at 45 now. All right. 45. Is it divisible by 25? Let's see. I see the 5. No. Okay. Is 45 divisible by 4? No. Is 45 divisible by 9? Yes. Okay. 45 can be written as, so we have our 4 still here chilling. And then we have 45 can be written as 9 times 5. So basically this is what we do right here. 9 times 5 was where we got the 45. Okay. And the 4 was still out there as well. So now I'm going to split this. Square root of 5, you cannot square root 5. It's a prime number. It's going to be square root of 5 is going to be the simplest. We can go with that. So I'll split this into multiplication of 3 square roots. Square root 4 times square root 9 times square root 5. Square root of 4 is 2. Square root of 9 is 3. And the square root of 5 is the square root of 5. And then we combine these on the left. 2 times 3 is 6 square roots of 5. So I also could have taken out 36 out of 180. 180 is equal to 36 times 5. And that, if you did the method that this paper actually tells us to do, you could have seen that 36 times 5, taking the square root of 36 and gotten 6 as well. But I think this is, for me, it's a little more clear to see kind of how to do it instead of having to check all the different perfect squares. All right, 242. Let's check a bunch. Okay. So 242 tried by 4. 242 divided by 4, 60.5. Okay. 242 divided by 9. No. 242 divided by, what's next? 4 squared, 16. No. 242 divided by, all right, I'm not really getting anywhere with this, right? Okay, I don't want to have to go through every single one. Now, maybe we can speed something up by saying it's something times 2. Okay, it's obviously an even number, so let's break it down and make it a little bit easier to go through. So, dividing 242 divided by 2, it's going to be something times 2. I'm putting 2 on the right because square root of 2 cannot be simplified. So, 242 divided by 2 is 121. Is 121 one of our perfect squares? It actually is. 121 is 11 squared. So we break this down. Square root of 121 times the square root of 2. This will be 11 square roots of 2. That one was nice. Okay. So there's different ways to go about doing this, of course. Just the main thing was that we're breaking it into some factors of perfect squares. Okay, and that's the front. Now we're talking about rationalizing a denominator. Okay, so remember we said for a number to be in simplest radical form, we need to have it in simplified if we don't have a fraction. But if we're in a fraction form, there cannot be any radicals, meaning square roots in the denominator. Don't ask why, I don't know, but it's just we cannot have that. So to do that, we need to use this little bitty trick. Okay, so let me ask you a question. If I have square root of 3, and then I want to multiply it by the square root of 3. Okay, so let's do that multiplication. It's going to be equal to, remember, 3 times 3 on the inside now. We can split them up, or we can also put them back together. And then that's going to be the square root of 9, which we know is 3. So how does this look? That's just whatever's on the inside, right? So anytime you multiply a square root by itself, meaning a square root of a number by the same thing, all that's going to happen is the square root symbol will drop and you're left with what's on the inside. Okay? So this is like anytime the formula is the square root of a squared is equal to a. If you square a square root, you just have what's inside the square root. Okay, that's our useful topic, and that's what we're going to use today when we rationalize denominators. So, let me just do an example with you. Alright, so this is what I have. 2 divided by the square root of 3. Okay? Remember we talked about if I multiplied square root of 3 times square root of 3, that square root sign would go away, which is what we want. We don't want it in the denominator. Okay? So, what if I just multiplied it by the square root of 3? Okay? However, fraction rules tell us that whatever I do to the bottom, I have to also do to the top. Okay? So, it means I've also got to multiply the top by the square root of 3. Okay? I'm essentially just multiplying by 1, because the square root of 3 over square root of 3 is 1. So let's do this, multiplications on top and bottom. We'll start with the bottom first. We've showed previously that the square root of 3 times the square root of 3 is just equal to 3. Okay, then you have a number 2, and then you have the square root of 3. So what can we do with this? Can we multiply 2 times 3? No. You can only multiply 2 numbers if they're both under the square root or both not in a square root. So all we can do with this is say this is just 2 times the square root of 3, or 2 square roots of 3. And we're done with that. That's all we can do. Okay? So next thing I want to check, same thing with division. I cannot simplify the square root of 3 over 3. One's in a square root, one's not. That's illegal, can't do that. Now we can see if this 2 and these 3 will simplify at all. It's just simplifying a regular fraction. 2 and 3 don't have any common factors, so that's in simplest form. So my answer would be 2 square roots of 3 over 3. Okay? You have to make sure we simplify the fractions too. Sometimes you're going to have to do a little more. It's not just the process of multiplying by the denominator. You got to do a little simplification sometimes. Not every time, but sometimes. All right, number 2. We'll multiply by the square root of 5 over the square root of 5. That leaves me, oh my god. That leaves me with 3 times the square root of 5. That's over 5. 3 and 5. 3 over 5 is the simplest fraction we can have for that, so we're done. So I've got negative 5 over the square root of 2. That don't matter. It's a negative whatever. Okay? No biggie. So, negative 5 over, we're still going to multiply by square root of 2 over square root of 2. Okay, when we do this, I get negative 5 square root of 2 over 2. 5 and 2 don't cancel. So that's my final answer. The negative's there. Doesn't matter that it's there. It's okay. Not going to change anything. Next. 4. We'll have square root on top and bottom this time. Okay, what does that tell me? The process is still the same. Okay, you can have a square root at the top, obviously. Let's get rid of the square root of the bottom first, though. Multiply both top and bottom by square root of 2. When I multiply the top, I have 2 square roots now being multiplied. Okay, what I can do is pull both of those numbers inside one big square root and say 3 times 2. This will give me the square root of 6. And of course, this is over the square root of, over just 2. Okay, can I do 6 divided by square root of 6 divided by 2? Can I divide that 6 by that 2? No, because one's in a square root, one's not. So square root of 6 is in simplest form, and we're left with just this right here. 5. Negative 3 over the square root of 3. Okay. Multiply by the square root of 3 over the square root of 3 to see if anything funky happens here. So on the top, this negative right here, I've got 3 times the square root of 3. This becomes just 3 on the bottom. Now, can we simplify anything? Of course. I have 3 over 3 both outside of a square root. Okay, 3 over 3, they cancel each other out. Still have this negative. We're left with negative square root of 3. Negative 1 square root of 3. Wonderful. Since the 3 on the bottom canceled out, that left us with a 1 on the bottom, which we don't have to write 1 on the bottom of a fraction. Alright, multiply by the square root of 10. So this on top becomes the square root of 20 over 10. Now, if I look at the square root of 20, can I simplify that square root whatsoever using what we did on the first part of what we were doing? Yes. Square root of 20 is just equal to square root of 4 times 5 over 10. So you can take the square root of 4 to give me 2. So I've got 2 times the square root of 5 over 10. Am I done yet? No. The fraction 2 over 10 can be simplified. And this will come out to, if I take out a 2 out of both 2 and 10, I'm left with a 1 out there. So we don't have to write 1 times the square root of 5. We can just say square root 5. Take a 2 out of 10, you're left with a 5. These do not cancel because one's in a square root, one's not. And this is my final answer right here. Square root of 5 over 5. Alright, almost done. 7. Square root of 3 over square root of 6, multiplied by the square root of 6. On top and bottom, I'm left with the square root of 18 over the square root of, over just 6. Okay, 18 is 9 times 2, so the square root of 9 times square root of, times 2 over 6. Square root of 9 is 3. This is going to be times the square root of 2 because we took the square that 3 out. Okay, 3 over 6, that's 1/2. So this will be the square root of 2 over 2. Nice. Square root of 2 over 6 this time. Multiply by the square root of 6 over square root of 6. So I've got the square root of 12 over 6. 12. We've simplified that before. It turns out to be 2 square roots of 3. This is over 6. 2 over 6 is going to be simplifying to this 1 over 3. So this is square root of 3 over 3. Again, you cannot simplify that because one's in a square root, one's not. And then number 9. Negative square root 20 over square root 45. Let's do the multiplication. So I've got negative square root of 20. Oh, excuse me. We're multiplying by the square root of 45 on both top and bottom. Alright, 20 times 45. Now I could do that. Actually, no, let's do it. I like it. 20 times 45. Let's do it. It's going to give me square root of 900. Oh, I can easily see what that's going to be. This is over 45. Okay, I see 2 zeros is 100. Okay, so now I can take that out. So this is going to be equal to negative square root of 9 times 100. Both of those are perfect squares. Square root of 9 is just 3. Square root of 100 is 10. It's over 45. Also, the square root of 900 is just 30. Okay, so this is negative 30 over 45. Not done yet because you can take we can take a 15 out of both of these. Okay, take a 15 out of 30, you've got 2. Take a 15 out of 45, you've got 3, and my answer is negative 2 over 3. And that is the whole entire worksheet or notes for this simplifying radicals. Okay. If you do have any questions, I might have went through it kind of quickly. You can slow the video down and go rewatch some of the parts. But if you have any questions, just shoot me an email. Thanks for watching.